Darcy's law is basically the law which governs the flow of the groundwater. ठीक है? So groundwater in a natural state is continuously flowing, as I have told you yesterday also. In natural state, it is continuous. In natural state, water is continuously flowing horizontally as well as vertically, right? Okay, and until unless there will be some impermeable bed, the water will not stop flowing. It will keep on flowing as more or less whenever it will pass through the beds of more or less same permeability. It will keep on flowing until and unless there is some obstruction, right? The obstruction which is known as the impermeable bed or the aquiclude. So basically water flow karta rahega, right? There will be various types of, एक minute, there will be various kind of geological formations of more or less same permeability which will keep allow its movement, water to fall through them, right? अभी भी लो आ रही है वॉइस? हेलो हेलो, ठीक है. Okay, so this is what we have. So now let's coming to the Darcy's law. What is there in Darcy's law? Darcy law में क्या बताता है? So how will we find the flow? कैसा हो रहा है water का flow? So to find out, as I have told you, aquifers are so large they runs through the miles. ऐसा नहीं है कि every single home has its own aquifer. It is not like that, right? What happens is basically one. So basically, as we know that these aquifers are so large, they runs through the miles, right? So how would we find that how is the flow of water, right? To find out how is the flow of water below the ground, what will we do? We will duct two wells at some distance from each other. Like this is one well, I will dig here, and after, for example, 200 or 300 meters, I will dig another well into this aquifer. Okay. So when I will find this, so this will tell us there are n number of things, as I've already told you. It is not necessary, guys, that in the same aquifer everywhere we will find water level at the same level, right? It's not mandatory that water table would be at the same level or at the same depth at every point in the aquifer, right? It might vary. So right, to find out the flow, we have dug two wells at some distance. So this distance between these two wells is known as flow distance. क्या बोलते हैं इसको? It's written here distance. This is actually known as flow distance, and it is denoted by small l. ठीक है? This is denoted by small l. Then the height, this is h1. The depth basically, h1 and h2 is, they will be having different water levels, like water tables. So h1 is the depth of that height of that water table of h1. Sorry, this is, for example, this is a well, right? And this is well named b. So the water level of the well A is h1. H1 means its height from the sea level is h1. Whatever will be the height from its sea level of A well will be taken as h1. The height from the sea level of well B will be taken as h2. ठीक है? Or we can say that these are the water table level. ठीक है? Or the depth of the water table. For example, if it is at 200 feet, right? It might be at 250 feet. ठीक है? हो सकता है. We can have water level or water table of two wells of the same aquifer, right? At different levels. This is quite possible. For example, this is at 200, this is at 250. These are two different depths. So this difference in the depths of two wells is known as vertical drop in the water table. क्या कहते हैं इसको? तो this is denoted by delta H. That would be H2 minus H1, whichever one will be deeper. ठीक है? इसमें कोई जरूरी नहीं सेम चीज सही करो, whichever one will be deeper, we just need to find the difference, right, between these two wells which were present in the same aquifers. But when we will dig in the same aquifer, when we will dig two wells at some distance, we will find a vertical drop. We might find a vertical drop. That vertical drop is denoted by H2 minus H1 or H1 minus H2. This is known as vertical drop in the water table. ठीक है, this is H1. Flow distance, I have told you, the distance between these two wells will be denoted by L, is known as flow distance. So now what Darcy law states is, we have discussed yesterday only, Darcy's law states that the movement of the groundwater is governed by Darcy's law, and it states that the amount of water flowing in a certain time in an aquifer की बात कर रहे हैं, right? So we will also need cross-sectional area of an aquifer. So the volume of water passing or in a flowing in a certain time, ठीक है, is directly proportional to the vertical drop in the water table, ठीक है, vertical drop in the water table divided by flow distance. This is what we have, ठीक है. And A is the cross sectional area of the aquifer. So A जो है cross sectional area will also be, ठीक है, directly proportional to the flow ratio or the volume of water flowing there per day. यहाँ पे हम per day का हिसाब लेते हैं. तो the volume of water flowing per unit time, ये भी किसके directly proportional होगा? It will be directly proportional to the area of cross section. ठीक है. So A is the cross sectional area through which water flows. समझ रहे हो? So that means A is also directly proportional to the volume of water flowing in a certain time. Have you understood, guys? आया समझ में? So तीन चीजें मुझे मिली. Q, the volume of water flowing per unit time is denoted by Q, या हम इसको flow ratio या flow rate भी बोलते हैं. We also call it flow ratio or flow rate. Fine. So this is Q, volume of water flowing per unit time. So this is definitely be directly proportional to the cross sectional area, क्योंकि definitely यहाँ पे cross sectional area of the aquifer will matter, and this is also directly proportional to the vertical drop in the periodic table divided. So I'm so sorry, water table divided by flow distance. So here we have got two equations, guys, right? This is equation 1 and this is equation 2. Now when we will equate these two equations, what will we get? We will get Q is directly proportional to, कोई बताएगा, A into del H, DH भी लिख सकते हैं इसको, delta H को, right? We can write it as DH as well or delta H, whatever. This is not minus, this is decimal, ठीक है, multiply मतलब ये लो, मैंने मोटा कर दिया इसको, जीरो नहीं है, अरे रब करना पड़ेगा, ठीक है. A dot, this is dot, अब dot मोटी बनानी पड़ेगी, A dot DH by L. So this is the equation that we have got. So now we can see that there's a here we have written the proportional. So to remove the proportionality, we will put some constant here, right? So that is the hydraulic constant or hydraulic conductivity, coefficient of permeability or hydraulic conductivity constant. ठीक है? Constant of hydraulic conductivity or coefficient of permeability will be used here to remove this proportional. तो इस proportional को remove करने के लिए क्या मिलेगा? Equal to, we will use, and that hydraulic constant or hydraulic conductivity constant is denoted by K. So now the equation will become Q is equal to K dot A, ठीक है, DH by L, ठीक है. So this is the final equation of the Darcy's law that we will get out of the definition. Have you understood or not? A is the cross-sectional area of the aquifer. The volume of the material जो है, उस material का cross-sectional area है, not wells, the aquifer guy. Do you know what is aquifer? Lokesh, have you joined late? Aquifer is a geological formation which is having water. So the volume of water present in that aquifer, right, the volume of water present will definitely be determined by the volume of the material. ठीक है? Clear? So that's why we will see the cross sectional area, because it is the cross sectional area of the aquifer. That means that is directly proportional to the volume of water flowing through it. Clear? Everyone clear? If anyone having any doubt, you can ask me. Do I need to repeat it? Okay, so final equation that we have got is Q is the volume of water flowing per unit time. So what we use here, volume of water क्या हो जाएगा? Meter cube, right? Volume is taken as meter cube. Per unit time we take here per day. ठीक है, per day का निकालते हैं, not per second, per minute, per day. So this is the unit of the volume of water flow rate or flow ratio. ठीक है? Actually, this is what we are calculating in Darcy's law, the volume of water flowing in, per unit area. ठीक है? Fine. What do you want me to repeat? Tell me. Whole thing. ठीक है? Now Darcy's velocity क्या होता है? Darcy's velocity is the velocity with which the water is moving within the aquifer, or water is flowing. Difference तो है ही. What if there is difference in the water levels? Water level mein you will find difference. That is why we will get DH. DH is the difference in the water levels, right? In the water table level. So this will help you find out the DH. You will easily be able to calculate. I will make you solve the questions, don't worry. But first let's learn the derivations. है ना? First see how is the equation of Darcy's velocity as well. So Darcy's velocity as well as Darcy's law questions I'll make you solve, don't worry. ठीक है? Okay, now coming to the Darcy's velocity, this is also a very important parameter, Darcy's velocity. So Darcy's velocity is the velocity with which water is flowing underground, right? Or with which groundwater is flowing. So to calculate Darcy's velocity, you need to know the cross-sectional area. अगर हमें Darcy's velocity calculate करना है, we should know what the cross-sectional area is. Okay. So it should be given for that. Generally, it would be given. So let's derive. Now you know the equation of, this is the Darcy's equation, right? Darcy's law equation, you know that. K dot A dH by L. It's not DL, it is L. ठीक है? Flow distance बोलते हैं. This is typing error. It is only L. Okay. So now what happens, guys? Darcy's velocity calculate karna hai. So what do you think is the formula of velocity? What does velocity means? Velocity is also, we're talking about the distance per unit time, है ना? तो बेसिकली वेलोसिटी क्या हो जाएगी? फ्लो रेट, है ना? फ्लो रेशियो पर यूनिट एरिया क्या होगा? क्रॉस सेक्शनल एरिया. फ्लो कैसा कर रहा है? वेलोसिटी जानने के लिए हम क्या करेंगे? हाउ इज द फ्लो रेशियो पर यूनिट एरिया. ठीक है? यूजिंग दिस we will get the equation of velocity. Velocity क्या होगा? How much of volume is flowing per unit time per unit area, right? So this is the equation that we will use to derive the velocity, Darcy's velocity. So V is equal to Q by A, flow ratio by cross sectional area. Now tell me, what is the equation of Q? Do you know what is Q? If you know what is Q, you can calculate Darcy's velocity here. Q क्या था? अभी equation पढ़ा. Darcy's equation is what? Darcy's law is what? K dot A dot DH by divided by L. यही है ना? DH by L. Now, okay. So, and here we have in this first equation, we had A divided by A. तो क्या हो गया? ऐसे हो गया? Divided by A. Now, this A will be cancelled by this A. So, what will be the final equation of the Darcy's velocity? V will be equal to K dot DH. It's dot. अरे K dot DH by L. आ गया? K dot DH by L. Have you got it or not? This is the Darcy's velocity equation. आपको ये दोनों equation याद करनी है. They will not give you the derivation. You just need to remember the equation. So if they will ask you Darcy's velocity, you will use this equation for solving the numerical. And if they will ask you Darcy's law, flow ratio or something like that, then you will use this equation. In this equation, this is not D, is not correct. This is typing error, right? DH by L hota hai. What is L? L is the flow distance. Clear everyone? Okay, now let me check. आपको मैं numericals देती हूँ. I'll give you numericals, then you will get to know whether it is right or not, whether you have understood or not. I would get to know. Okay, before this, I want to tell you some dimensions. This is a very big mistake that the students do, guys. Actually, they get confused. You know, sometimes the language of the numerical is so tricky that students get confused whether what are they asking. They're not able to find out what they're asking actually. तो क्या होता है डार्सीज वेलोसिटी में v, दिस इक्वेशन में v वाज द डार्सीज वेलोसिटी. सो वेलोसिटी इज वेरी सिंपल थिंग. व्हाट इज द इक्वेशन फॉर द वेलोसिटी? किसी भी टाइप की वेलोसिटी हो, मीटर पर सेकेंड या मीटर पर यूनिट टाइम, होता है कि नहीं? That will be the value of the velocity. Simple सी, ठीक है. And in case of Darcy's law, if you remember, I have told you the time unit for time is taken as per unit day. So the Darcy's velocity will be meter per day. Okay, clear? So then generally we have equation for velocity as meter per second, meter per unit time, area per unit time. So what will be here? Meter per unit day, per day. So meter per day is the dimension for Darcy's velocity. Then hydraulic constant का calculate करना है, that I will tell you कैसे करेंगे. For example, what is the formula for velocity? The formula for velocity is, what was the equation that we got? K dot dh by L. ये है. This is the equation. Now let's find out what will be the derivation dimension for k. हमें calculate करना है. How will we calculate? The velocity का formula क्या था अभी बताया? Meter per day. Meter per unit time होता है. This is meter per day, right? Now is equal to, we have to calculate the value of k. Let's write it as k. Then dh was vertical drop. How will we calculate it? ये मीटर में होगा कि नहीं होगा? You know that vertical drop will be definitely in meters, है ना? जब हम मीटर में बात करें everything, so we will take is m. We will calculate in m. इसकी जगह m लिखे. Then L is the flow distance. What should be the value or parameter or unit of flow distance? Please tell me. What will be the unit of flow distance? फ्लो डिस्टेंस को हम किस यूनिट में मेजर करेंगे बताइए? मीटर, किलोमीटर, सेकंड्स, किलोग्राम, ग्राम? कॉमन सेंस यूज करो. yes, it is meters, so let's use it, meter. So now looking at this equation, this will be cancelled this by this. So what will become the unit for k? K's value is meter per day. Got it everyone? So the value for the unit for coefficient of permeability or hydraulic constant is meter per day. Now why I'm taking time to explain you the dimensions? Because guys, the value, the language of the exam is very tricky. Now if you will not be able to get what they are asking, and if you have got confused and you're not able to find out what is being asked in the exam, you just see, be smart and just see what values are given in the answers. जैसे कि आपको समझ में नहीं आ रहा है, they have asked for k or they have asked for q. So remember, well, if the answer is in meter per day, that means they have asked for k, hydraulic constant. If the if the equation has been given as meter cube per day, flow ratio क्या होगा? Flow ratio will be volume of water flowing per unit time. That will be meter cube per day. So q will be meter cube per day and k will be meter per day. Got it? Clear everyone? Clear? I hope you would have understood it. Now let's do the numericals, है ना? Until unless you are not able to deliver what you have studied, it is of no use, right? Let's see what question comes. I'll give you a question. Can I give you a question now? Don't do cheating. Okay, write down. Write down, given that vertical drop in the water table is 2 meters, vertical drop in the water table is 2 meter, right? And the thickness of the aquifer is, thickness of the aquifer is 20 meters. Thickness of the aquifer is 20 meters, right? While its width is 1 meter, while its width is 1 meters, flow distance is, flow distance is 500 meters. Flow distance is 500 meters. ठीक है. Coefficient of permeability is 50 meter per day. What will be the volume of water flowing per day? Volume of water flowing per day का मतलब क्या हुआ? Q. What will be the Q or flow ratio or volume of water flowing per day? Tell me. Please use the equation. So how would we do it? Yes, we have to calculate Q here. So how will we do it? Q is equal to, I'll give you 1 minute more. इतना टाइम नहीं होता यूजीसी में. जिनको नहीं आया उनके लिए देख लीजिए एक बार. I'll do it for you. फॉर्मूला क्या होता है फ्लो रेशियो का? इज K डॉट A DH by L, राइट? K डॉट A, गलत, लोकेश units are wrong. Meter per day is not the value for flow ratio. K dot A DH by L. So now value of K is what? 50 meter per day, right? Cross sectional area कैसे निकालेंगे? Two dimensions are given, thickness and width. When we will multiply thickness and width together, we will get 1 into 20, that would be 20 meter square, right? This is the cross sectional area. Now DH is the vertical drop, meter cube per day. Vertical drop in the water table is 2 meters divided by flow distance. Flow distance is 500 meters. Now what is it? 50 into 20 क्या हो गया? 5 2 are 10 और 0 0 1000 ऐसे ही हो गया. Into 2 2000 divided by 500. ऐसे ही कट पीट कर लो. ये इससे कट गया, ये इससे कट गया, ये 2 0 कट गए और ये 5 से कैंसिल आउट हुआ. Now what we will get? We will get 4. This is 4 meter cube per day. Fine? Fine, guys? Now there is one more. Okay, then with the same dimensions, what will be the Darcy's velocity? Tell me. With the same dimensions, calculate Darcy's velocity for me without wasting any time. सबको समझ में आ गया? शर्माइएगा मत. If you have not understood, please do ask. I'll give you 1 more minute. I'll give you 1 more minute. Okay. Those who have done, good. Those who have not done, just have a look here. Okay. So we have asked Darcy's velocity. What is the equation for the Darcy's velocity? V is equal to K dot DH by L. A नहीं होता इसमें, आपको पता है. तो नाउ K की वैल्यू क्या है? K's value is 50 meter per day. Right. Now what is the value of DH? DH is the vertical drop, that is 2 meters divided by flow distance. Flow distance is 500 meters. 50, 500 कटा, this is 10 बचा, ये ऊपर जाएगा. So what will it become? 0.2 meter per day. Those who are replying, please, your answer is not correct until unless you have not given the dimensions, right? You should know what will be the dimension of your answer. Clear, guys? So this is what? This is 0.2 meter per day. This is the Darcy's velocity, and this is how you will calculate it. These are quite simple numericals, but they will give you definitely for sure. Darcy's law is very important topic. 99% you will get a question from this. Clear? Clear, guys? One question will 100% be there, and there might be two questions. So from this chapter, hydrology, groundwater. Okay, now that this topic is over, now we will move to the next topic, groundwater pollution. Right? Groundwater pollution तो आपको रंजन मैम नहीं पढ़ा रही है ना? Fluoride pollution. Okay, so we will do fluoride pollution now, groundwater pollution. Okay, so now we will do with the groundwater pollution. So groundwater pollution may the major, as you know that surface water as well as groundwater also gets polluted, right? It's not like that groundwater cannot get polluted. There are various pollutants which actually pollute the groundwater. So one of these is fluoride. Fluoride pollution, the major, you know, water source that gets polluted by fluoride is the groundwater, and the source of fine. So basically what is happening, what happens actually, fluoride pollution, how will it cause, it'll be occurring, of fluoride pollution will occur due to the fluoride rich soil. There are few types of soils or minerals which are rich in fluoride. So they will act as a source of fluoride pollution. जैसे कि the soils which are rich in fluoride are fluorite, apatite, mica, amphibole, right? So these are the various types of minerals which are rich in fluoride. So wherever we will have such minerals, and if we will be having groundwater there, right, or if the extraction of the groundwater from such sediments will be taking place, that will result in high level of fluoride in the groundwater. Okay? So you should know, as you know that in the pollutants, you should know the sources, the causes, the harmful effects of those pollution. So fluoride is a groundwater pollution. Major sources are the fluoride rich minerals. Remember also what are fluoride rich minerals? Exam में पूछा गया है. Fluorite, apatite, amphibole, mica. And sometimes excess use of fertilizers which have fluoride, they also cause an, as a source of fluoride. Clear? Now, guys, fluoride is also known as a double-edged sword. Double-edged sword means do dhar wali talwar. Right? As you know, as the chromium. One form of chromium trivalent is an essential nutrient, but chromium hexavalent is highly carcinogenic. This is same. When we have, अगर आपने सुना होगा आपके टूथपेस्ट में फ्लोराइड है, बीच में आता था एक फ्लोराइड वाला टूथपेस्ट. Actually, when there is low concentration of fluoride, it is good. It has remarkable effect on our teeth or dental caries. It prevents the dental caries, right? So when the value is less than 1.5 ppm, it is good for dental system. It inhibits the dental caries, right? But if the fluoride concentration has reached more than 1.5 ppm in the water, it will have opposite effect on dental system or our teeth and the skeleton, right? If the amount of fluoride that has reached our body is more than 1.5 ppm, it will lead to molting of teeth and deformation of bones. Got it? So if the concentration of the fluoride is less than 1.5, it is very good for our teeth. But if it has crossed that limit, it will cause molting of teeth and deformation of bones as well, which is called defluorination of bones. Okay, fine. Okay, and it will cause dental fluorosis. इसको बोलते हैं dental fluorosis and or skeletal fluorosis. In this way it affects the our teeth and skeleton. Clear? Now, okay guys, clear na? कोई problem तो नहीं है? Now let's see what is written here. Fluoride shows a positive correlation with the following. Okay, one thing I want to tell you here. Do you know what is ppm? ppm means parts per million. Everyone would be knowing that. But when we are talking about the concentration of this pollutant in water, that means 1.5 ppm means 1.5 milligram. No, it's milligram. 1.5 milligram of fluoride per liter of water. ठीक है, mg per liter is equal to 1 ppm. 1 mg per liter is equal to 1 ppm. So 1.5 ppm means 1.5 mg of fluoride will be present per liter of water. ठीक है, clear? This is fluoride. This is your ppm. Now, fluoride show positive correlation with the following. Positive correlation means the concentration, right? Concentration will reach with increase. Positive correlation क्या होता है? Directly proportional in a manner. In general terms, you can understand it as directly proportional. Means if one parameter is, when we take two parameters in relation to each other, if the value of both the parameters increases with each other, for example, that means if I would say fluoride is showing positive correlation with the pH, that means if the pH is increasing, the fluoride concentration is also increasing. Got it? So if the pH is increasing and fluoride concentration is also increasing, that means pH is increasing means alkalinity is increasing. आया समझ में? If pH would decrease, the acidity would increase, and if pH would decrease, the acidity would increase, and if pH would increase, the acidity would decrease and alkalinity would increase. Clear है ना? सबको pH का concept तो पता है. Is there anyone who is not aware of it? Anyone having any doubt in pH? So you can ask. शर्माना नहीं है. Okay, so can you see that, guys? Fluoride is showing here, what is written? Fluoride is showing positive correlation with pH, carbonates and bicarbonates. Can you see anything in common here? That means actually pH means increasing means alkalinity. And alkalinity, how is alkalinity increased? High alkalinity alkaline substance will be having, or water will be having, high concentration of carbonates and bicarbonates. Remember, alkalinity of water will be determined by, I think मैंने आपको ये लिखवाया भी होगा, if water is having high alkalinity, that means there is high concentration of carbonates and bicarbonates, right? High concentration of carbonates and bicarbonates. So alkalinity is directly proportional to carbonates and bicarbonate ion concentration. Clear? So this is how we can say that fluoride is directly proportional or showing positive correlation with pH. If pH will increase, that means carbonates as well as bicarbonates are increasing with the fluoride, or with the increase in the pH and carbonate and bicarbonate concentration, fluoride concentration increases. Clear? So this is what we have about fluoride. Okay, now you should know what is the treatment method of fluoride. आपको पता है ना, आंध्र प्रदेश में प्रॉब्लम बहुत थी. So नालगोंडा एक गांव है. Okay, I'll also talk about the negative correlation. Nalgonda technique, right? Nalgonda technique is the technique which is used for the removal of excess fluoride from the water. And this is there was a village named Nalgonda. The local people had, high level of fluoride pollution in their water, groundwater. So they came out with a technique. What was that? In that technique, they have used, actually, this question has come in the UGC. What is used in Nalgonda technique? Actually, fluoride pollution is really, reduced by use of calcium hydroxide. Because जो fluoride होता है, it shows negative correlation with calcium and magnesium and hardness. With the alkalinity, it shows positive correlation, right? But with the hardness and calcium and magnesium ion, it will not increase. ठीक है, यहाँ पे अच्छा figure है, मैं क्यों मेहनत करूँ? See here, they have given this. Right, fluoride concentration will decrease. Higher the concentration of the lower the concentration of the calcium and magnesium ions, the higher would be the fluoride concentration. So hard will be the water, harder the water, okay? So less will be the concentration of the fluoride. So fluoride is showing negative correlation with the hardness. And you know that hardness of water is hardness is of two types. Pata hai? Those who don't know, please do write down. Hardness is of two types. One is permanent hardness, the other one is temporary hardness. So generally, whatever the hardness is because of the calcium and magnesium ions. Okay? Right? Calcium and magnesium ions causes hardness of water. Now, temporary hardness is caused by carbonates and bicarbonates of calcium and magnesium. Okay? Carbonates and HCO3 negative and bicarbonates of calcium and magnesium. Please remember this, they will ask you this question in UGC. And permanent hardness is because of the chlorides भी होते हैं, nitrates, sulfates, chlorides, ठीक है, सबकी वजह से. ठीक है, clear guys? So basically hardness is with the, so whenever, so as you can say that, see that this is showing negative correlation with the calcium and magnesium ions. So if we will add something which would be having high number of calcium and magnesium ions, this will reduce the concentration of fluoride. So this is how calcium hydroxide, what it does, calcium hydroxide reduces the concentration of fluoride. So there was a village in Nalgonda, they came out with a technique of reducing the fluoride content by using calcium hydroxide and aluminum hydroxide. ठीक है, by using calcium hydroxide and aluminum hydroxide are used in Nalgonda technique. This question has been asked and UGC can ask this question. How is fluoride treated in Nalgonda technique? By calcium hydroxide and aluminum hydroxide is added, water is passed through it, fluoride rich water. उसके बाद क्या होता है, that water will be having, sorry, the fluoride content will be cleared through it. ठीक है, ठीक है. So this is how water can be treated or water can become free of fluoride. ठीक है, this is the end of